Welcome to the June 2023 AQA Level 1 Further Maths GCSE Paper 1. This is the non-calculator paper. Question number 1, we're given a function. We've got to work out the value of x when the function produces the value -5. So I'll equate -5 to 2x plus 1, solve the equation x is -3. Compound function f of g of 3, if we do g of 3 first and get 9, and then plug 9 into f of x, we get 19. You can construct a composite function if you want to. I didn't. It comes out as 19. For question 2, full factorization, we need to factorize out 3xy, and that would give us 2x plus 7, lots of it. The matrix that represents a reflection in the line y equals minus x is 0, -1, -1, 0. My recommendation is just learn them. There aren't that many to learn. For the matrix multiplication, I'll take the two matrices they give us, multiply them together. It's a show that question, so I am going to show an extra line of working for the calculations, -6 plus 4, -8 plus 8, 3 subtract 3 and 4 subtract 6. Simplify that down to -2, 0, 0, -2, and factorize sort of out the -2, so -2 lots of 1, 0, 0, 1, and there's my identity matrix, so we get that's going to be -2 lots of I, not 2i. There's an error there for you. Question 4, find the gradient of the line. 2 subtract -4 over 7 subtract 5 is 6 over 2, so the gradient of the line is 3. To work out the distance between the 2 points, we're going to use Pythagoras. The square root of the difference between the x-coordinates squared and the difference between the y-coordinates squared comes out as a square root of 2 squared plus 6 squared, which is 4 plus 36. Square root of 40, and I'm going to simplify my answer down, so I'm going to pull out a 4 from that, so root 4 times root 10, which is 2 root 10, and 2 root 10 is the answer. Alright, question number 5. We're given 2 sequences in terms of n, and we're asked to show that the difference between the 2 sequences is a multiple of 3. So if we take yn, subtract xn, replace the nth term versions of those. I'm going to expand out both the sets of double brackets. Be careful when expanding out the right-hand pair, because we're subtracting the expansion. I'm going to leave a set of brackets in there just to show that clearly. And then when we do the 2 subtract -1, it comes to the plus 3. Factorize the 3 out, and we can see that's quite clearly a multiple of 3. Question number 6. So this one's to do with calculus. We're going to work out the equation of the tangent at the point 1, -2. So let's find the gradient. First of all, I'm going to differentiate times by the power subtraction. The power gives me 6x to the 5 plus 8x. At the point when x equals 1, substitute x equals 1 into my differential. We'll get 6 plus 8, so the gradient is 14 at that point. And then we can use y minus y1 equals mx minus x1 to get the equation of the tangent. It wants it in a specific form, y equals mx plus c, so I'll expand out the right-hand side and bring the plus 2 onto the right-hand side. Subtract 2 from both sides if you prefer. Y equals 14x, subtract 16. Question 7. We've got a cone and a prism, and it tells us that the volume of the cone is 4 times the volume of the prism. That allows us to to construct an equation. So the volume of the cone, 1/3 pi r squared, h is x, so I'll replace the h with an x, is going to be 4 lots of the volume of the triangular prism, which is x lots of a half y squared. It's the area of the cross section times by the depth. Then it's just a case of playing about with the equation, cancelling things that cancel, and then rearranging to make r the subject. We end up with the square root of 6y squared over pi. Question number 8, we have a circle that centers 0 and a radius of 5, so the equation of that circle is x squared plus y squared equals 5. And we have a straight line 2y equals x plus 5. Essentially we have to solve these simultaneously, so I'm going to make x the subject of the linear equation and then substitute that into the quadratic. To the non-linear. This is a circle, not a quadratic. So replacing x with 2y minus 5, we've got 2y minus 5 squared plus y squared equals 25. Expand out the 2y minus 5 squared to give us 4y squared minus 20y plus 25 plus the y squared is equal to 25. We now have a quadratic, so I'll bring everything onto the left-hand side to equate it to 0. It's a special case, so single bracket factorization. 5y, y lots of 4 equals 0, so the two y values are 0 or 4. And we can work out the two x values from that, so x will be negative 5 when y is 0, and x will be 3 when y is 4. Substituting it into the linear equation to work those out. So the 2 points are minus 5, 0 and 3, 4. Question number 9, we need to rearrange the equation to make y the subject. We can multiply both sides by the denominator, so multiply both sides by y squared minus 2. I'm going to expand the left-hand side immediately. wy squared minus 2w equals y squared plus 5. Then I'm going to bring all the expressions with y squared onto the left-hand side and all the expressions that don't have a y in onto the right-hand side. And that allows me to factorize out y squared from the left-hand side. And the last but one step will be to divide both sides by w minus 1 and then square rooting both sides. We can get y equals the square root of 2w plus 5 over w minus 1. Question 10, simplifying a surd. Multiplied by its conjugate pair, so I'm going to multiply the top and bottom of the surd by 3 plus root 5, which is of course the equivalent to multiplying by 1, so it doesn't change the value of the expression, it just changes the way it looks. Anyway, carrying out double bracket expansions, the top 3 plus 3 root 5 plus root 5 plus 5, and at the bottom we're going to get 9, subtract 5, the irrational parts will cancel, and that simplifies a little bit to 8 plus 4 root 5 over 4, and then simplifies fully to 2 plus root 5. Question 11. Tells us that the second derivative is 55 at this point x, and can we work out x? So I'm going to differentiate twice. Differentiate once, we get a third x cubed plus 6x. Differentiate a second time, we'll get x squared plus 6. We can equate that to 55 and then subtract 6 on both sides. X squared equals 49. And therefore x is equal to 7. It tells us in the question that we want the positive value of x, so I should ignore the fact that negative 7 would also be a solution. Okay, x is 270 for sine x to be minus 1. You should just know that one. If you don't know those important points, do go and learn them, there aren't that many. For b, tan of y is 1 over root 3. Rationalize that, root 3 over 3 if you want, depends how you like to remember these. Anyway, again, you should have learned that those values will be 30 and 210. You can add 180 to each one with tan to find the next one if you forget. Question 13, adding together the three expressions, I'm going to create a common denominator of 3x. So for the first fraction times the top and bottom by 3, I'll leave the second fraction alone and I'll rewrite 1 as 3x over 3x. Join them all together with the numerators, 9x minus 10 over 3x. Question 14, because x is positive, it is a legitimate step to multiply both sides of this inequality by x without having to worry about any inequality direction changes. And that gives us a 3-term quadratic. Bring it all onto one side, factorize it. We want the values of x that are below the x-axis, and so we want the values of x that are in between those two critical values of 4/3 and 2. So x will go in the middle there for this one. Question 15. So expanding the double brackets on the left-hand side, x to the half times x to the half is x. Then we're going to get x to the half times x to the 3/2 is x squared, so it would be minus 2 lots of that, and x to the 3/2 times x to the 3/2 is x cubed. Bring everything onto the left-hand side, and we get the x's cancel, factorize out an x squared, and we can read off the two solutions. They're going to be 0 from the x squared and 3 from the x minus 3. Question 16, if you have expanded absolutely everything out, that's not wrong, it's just not particularly efficient. I'm just going to concentrate on the bits that I'm interested. So I'm only going to concentrate on the parts of the expansion with the x squared component. There's a little Pascal triangle to help me. So we're looking at the third term of the fourth row, so that's 6 on the Pascal triangle. So 6 lots of 1 squared times 12x all squared from that first expansion. From the second one, we're going to get the 3, this is the 1, 3, 3, 1, 1. We're going to get 3 times a times and then 4x all squared. Now we know the coefficients of x squared are the same, so the coefficient of the x squared in the first one is going to be 6 times 1 times 12 squared, and the coefficient of x squared on the second one is going to be 3 times a times 4 squared, so those must be equal. And just break these down to make it easier. I could calculate both of those and carry out a long division, but if I break them into their prime factors, I can do a lot of cancelling just to make my life a little bit easier. Break 12 squared down up into 3 squared times 4 squared. It cancels nicely with stuff on the right hand side, leaving me with a to be 2 times 3 squared, or 18. If you did 6 times 144 and then divided by 48 or whatever it is, that would come out as 18 as well. Question 17 tells us that it has a stationary point at -2, 11. Actually, the fact that it passes through the point -2, 11 is useful in and of itself, because we can substitute x to be -2 and y to be 11 straight into the equation, and it gives me an equation in terms of a and b immediately. Then, because it's a stationary point, the derivative at x equals -2 will be 0. So I differentiate the equation and equate it to 0. I'm going to substitute -2 into the equation, and that gives me a second equation to do with a and b. And essentially we've got a pair of simultaneous equations. At this point it doesn't matter the way you go about solving them. I've just added the two equations together to cancel b and work out a, but there's a whole number of perfectly legitimate ways of solving those simultaneous equations. You do a substitution or whatever. Either way, if you do it correctly, you should come out with a equals 1 and b equals 3. Question 18, so a 3x3 set of simultaneous equations. This is one way, this is the algebraic approach. There are other approaches, row reduction. You could do 3x3 matrices if you fancy doing that. There's a number of ways of solving 3x3 sets of simultaneous equations. I've done it by rearranging some of the equations and then eliminating x and then eliminating z to work out y first. And once you've worked out one of the values, you can just substitute it into another equation to work out the other two fairly straightforward. So I take my equations that I've labelled 4 and 5, add them together, and it eliminates the z's from those two. Minus 11y equals minus 33, y equals 3. And again, once you have one value, you can go to any of the equations really and start working out x's and z's. If you've done that correctly, you'll get x equals 5, y equals 3, and z equals -1. Okay, question 19. We're going to complete the square with the left-hand side. So the first thing I'm going to do is factorise out 8 from the first two parts of the expression. So it'll be 8 lots of, and then x squared. And then 20 over 8, so I've simplified down to 5 over 2, lots of x, plus the n at the end. And then we complete the square with what's inside the brackets, so I'll leave the 8 alone. Half of 5 over 2 is 5 over 4. I always find these are easier to do when they're listed as fractions, because you can then square that easily, 25 over 16. And then when you expand that out, 8 lots of 25 over 16. The 8 and the 16, if you like, will cancel. You'll be left with minus 25 over 2. Plus n. And that's equivalent to, it tells us in the question, c lots of x plus d squared plus 3. And we can read off that c must be 8 and that d must be 5 over 4. And all that remains is for us to find n. So we'll have minus 25 over 2 plus n equals 3, or you can write that the other way around to keep it tidy, times everything by 2, bring the 25 onto the right hand side and halve it, and we'll get n is equal to 15.5. So c equals 8, d equals 5 over 4, 1.25, and n equals 15.5, 15.5. Question 20. I'm actually going to use the cosine rule twice on this one, on the two separate triangles. The first cosine rule I'm going to use is going to be on the triangle PQR. I know that angle PQR is 60, it's half the angle at the centre, using the circle theorem. And so a squared equals b squared plus c squared minus 2bc cos a. 60 is quite a nice angle because cos of 60 is a half. So substituting the numbers in and calculating them, 2 times 4 times 5 is 40, and then cos 60 is a half, that simplifies to 21, so PR is the square root of 21. Now if we do the cosine rule again on the triangle POR, each of the side lengths PO and OR are both little r, the radius of the circle, which is what we're trying to find here. We can get PR squared equals r squared plus r squared minus 2r squared cos of 120. PR squared we know is 21 from the first bit of working. Collect the r squareds together. Cos of 120 is, of course, minus a half. And so we get plus r squared at the end. The last bit collects to 3r squared. Divide by 3, square root it, r must be the square root of 7. And we're done.